If you're looking for a technical tutorial explaining how to collect logs from your Kubernetes cluster utilizing the OpenTelemetry collector, then this episode is for you. Welcome back to the Easy Observable YouTube channel. Today's episode is going to be a technical tutorial utilizing the OpenTelemetry collector. You probably have seen an episode explaining how to collect logs utilizing the OpenTelemetry collector, explaining in details the OpenTelemetry transformation language and the various receivers and connectors. This episode here is obviously not going to explain the various aspects, but it's going to show you how to do this through a tutorial. So what do you expect from this episode? So first we will explain the various requirements related to the tutorial, the environment that you will need. Then once you have deployed the script, there are a couple of things that we now need to double check. So we walk through those requirements and then we will go in details, first covering the receivers, so the file log receivers, how to configure it, then looking at the connectors, how to configure a routing connector to route the logs through different pipelines depending on the format. And then last piece will be the processors with the transform processors. Basically, the transform processors will process the logs differently based on the container runtimes of logs. All right, if you enjoyed today's content, don't forget to like and subscribe to the channel. So let's go for the tutorial. In this tutorial, we will create an OpenTelemetry pipeline parsing our Kubernetes logs based on the format. We will use Kuma that has a specific log format based on the protocol. Remember, there's a format for HTTP and there's a format for TCP. So we will try to enrich our logs, adding extra attributes to our log stream. In this tutorial, we will need a Kubernetes cluster, the Certmanager, which is a requirement for the OpenTelemetry operator. We will deploy the Kuma control plane. We will add the OpenTelemetry demo as a data plane of Kuma. And of course, all the data, the logs, the metrics and traces will be sent to Dynatrace. We'll configure the right pipeline to manage the access log produced by Kuma, but also to enrich the logs that we're reading from the file log receiver. Every tutorials that we deliver here at Is It Observable, there is always a GitHub repo, and here you're looking at the repository related to OpenTelemetry logs. So a couple of requirements as usual, I explained them. If you don't have a Dynatrace tenant, you can click on this trial link that will allow you to put your email and start a fresh new trial. And then there are a couple of requirements we need. First of all, the Dynatrace tenant URL. So what you would do is, if you open your Dynatrace tenant, you will pick everything which is here, the first piece before the /UI. That will be your tenant. So everything until.com, and the rest, we don't need it. Then we need to create an access token. So you can press Ctrl-K here and type token. All right, and you will see here per access token. So you click on this one, it will bring you to the access token page, and we will click on the top right, generate a new token. And from there, as usual, we'll give a name. So I already have created my token, so I don't have to create it, but you will need a name for that token, and then you will search for ingest. And in our case, we're gonna ingest logs, metrics, and traces. So you click on those three boxes, and then you click on generate token. Once you have clicked on generate token, you will have the token value displayed only once. So copy that value, save it into this variable called data ingest token, and then once you have that, you can go further in the deployment. So you will have to get the Kuma CTL, because here we utilize Kuma. You will have, of course, to set the Kuma CTL in your path. Once you have it, you will be able to run the deployment script that will, in fact, use the Kuma CTL. So what you will get is with this deployment. So first, let's look at the namespace. So in the namespace, you can see that we have the Otel demo namespace created. The Kuma system namespace for the Kuma control plane is here. And then we will have the default namespace. The other one are technical due to the Certmanager and the OpenTelemetry demo operator is there. So what you will find in those two main namespace, Otel demo in one end and default on the other one. So let's check it out. So if you look at the Otel demo application, you will see first a gateway deployed that is exposing the IP address of the Otel demo. Second thing is you will have all the workload related to the OpenTelemetry demo. Front-end proxy is crashing, not a big deal because at the end, we don't need that. We will basically, the load generator will reach out directly to the front end. We have two containers in each of those pods. Why? Because we have in one end the application pod, on the other one we have the envoy. I mean the sidecar proxy just injected by Kuma. So that's what you're gonna get. Then in the default namespace, you will get two, in my case, two OpenTelemetry collector running. There's already a default pipeline that we will adjust to use now the OTTL language to transform and other things that I explained during that episode. So that's what you're gonna get. Last one, maybe one last thing is if you go to Dynatrace, the logs are currently collected with the file log. So we're gonna modify file log. Metrics are also sent to Dynatrace and traces as well. So if you go to your tenant in Dynatrace, you click on services. So here, if you don't have services, you simply have to type Control-K, services, and it will bring you the services application that you can open. And if you look at this service application, we can see that we have a lot of services from the Otel demo. So all the traces are coming in. So if you pick the checkout, for example, we will see that we have some response times, the dependency, the topology is here. And if we click on one of the trace, you will see all the spans of that given trace with the ingress and egress. So every single sidecar is producing spans like explained in the Kuma episode. Then other thing, we have metrics. So same thing, if you don't find that metrics, you type Control-K, you search for metrics, and it will provide you the metric application. So if I click on this one, you will see that I have all the metrics. And if I go to the last page, for example, you will see that I have envoy metrics coming in. I have a lot of various metrics, envoy. There's a lot of envoy metrics, in fact. And if you go further down, you will see that we start to have like Kafka application processes and other things that are generated by the Otel demo applications. Let's have a look at our files that has been deployed. So in this repo, I have two files. So this is the solution, but the other one is the one that we're going to work on. As of now, the pipeline is doing a lot of things. So let's describe that pipeline. So as you can see, we have the Prometheus receiver that is collecting the Kuma data plane metrics. We are also relabeling and doing some changing on the naming on the metrics. We're also collecting the OpenTelemetry collector metrics as well. And then you can see that we have the file log. So, but before describing the file log, let me go back down and you can see that I already have some couple of processors in place. So the cumulative to delta to transform the Prometheus metrics into the delta metrics for Dynatrace. Then we have the filter where here I'm dropping a couple of metrics. As you explained, filter, here I define the scope of metrics, and here you can see that I am removing all the metrics that are with the type histograms, and if the metrics start with this giving name. We also have the Kubernetes processor attribute that has been configured, so that I'm not going to describe everything. And also I'm adding a transform metric. So this is more to avoid having units that are not respecting the schema. So if I see that if there's a dash in the unit, I'm replacing with empty, and same thing if the name of the metric is under 4 characters, I am adding some extra content in front of it. And last, I am creating this transform to set that if the aggregation temporary is defined to cumulative, then I set this resource attributes to true, and you'll see that will force the routing. So because at the bottom I'm already creating a connector with the routing metrics, so testing that specific resource attribute, saying that if the attribute resource attribute, because here it's only on the resources, has the cumulative equal true, then I go to the pipeline metric conversions. So this is basically what you would get. So 1 pipeline for traces, 2 pipeline for metrics. In fact, it's basically because it's using the routing metrics. So all the metrics go through the default metric pipeline, and then you can see that we're filtering, and then we're going to transform metrics that adds the extra attributes, and then here we have the metric conversion. So if based on the routing, based on this routing, this will be called because of this condition, and it will basically force the conversion here. So if there is any metrics that are considered to be cumulative, it will be converted through that route connector. And then I need to have a default pipeline in case, which I've defined here, where I don't have any cumulative delta. And last, logs. At the moment, logs, you can see we are receiving OTLP, we are receiving file log, and then we don't do much. And in fact, at the moment, most of the transformation that has been applied in the logs format is done through the file log receiver. As you can see, we're reading all the logs. We are adding the file path in the attributes, and then we have a bunch of operators. So routers, so based on this route here, we can see that there is various the operator for stanza allow us to do similar thing than the connector. So based on the body, if it's this section, it means it's going to be the parser Docker. This one is going to be for the cryo, and then container D. So that basically call the right operator action. So here you can see that container D is existing. It is here. So you see ID container D. So you can see that here it's basically collecting those things and generating that to this extract metadata file path. And at the bottom, what it does is taking this extra data path to rename it to the right, container name. So we can basically do just the pipeline and remove few things. So the first thing that I want to do is basically drop everything that we have here. All right. So let me drop the regex parser, because this is going to be done through a transform processor. Then we're also going to move this piece, so the body, same thing. We're going to move this. We don't need this piece here. We're going to move that part. And last, what we're going to do is we have detected the format. So now what we can do instead, we can say move. We can, instead of a regex based on the format, we can add typically just a simple attribute to say that it's a container runtime. So let's remove this, add, and last, 3 output defined. And now I can see in Dynatrace. So before we apply it, let's look at the logs coming in. So let's go to open notebook. On the left side, you have a notebook access. And here I'm going to do fetch logs, and then we're going to say from the last 30 minutes. All right, so you can see here, let's change the display to have a better display. Record like this. So what we can see here, we don't have any container runtime variables. We have the Kubernetes container name, we have the pod name, we have the namespace. We have lots of already some information. We have the log here. So we have log and content. So because this is due to the fact that Stanza is adding log, so it's been added. So this is really the Stanza format. So now, if we apply that, you will see that a lot of things will not be as detailed as that we are seeing here. So let's apply this our changes. Okay, let's check at the pods. Now it's creating, and this one should be created as well, but it's terminating, so it will take a few seconds, but it should be there. So now let's rerun that query now. All right, so now you can see the logs now is obviously there's less attributes with the change we've done. So first we have no log level, we have no status, but we have now the container runtime Docker. And you can see the value here is there's a lot of things to do, and we have a lot of metadata missing. So we need now that we have the container runtime to first create a routing rule with a connector, and then we will do the processors. To move further, we are going to introduce to our current pipeline. We already have a routing rule at the bottom here on the connectors for the metrics. So now let's do another one called routing, and then we define a default pipeline. So now it means that we have this. So which means what I'm going to do here, I'm going to say, I'm going to receive logs, okay, Otel from Otel OpenTelemetry, which is Kuma, and the file log. And then I'm going to go through memory limiter. And then what we're going to do is we're going to do called routing logs. So that will be our memoriator, and then routing logs here. We will have several pipelines. So we have so now I've added those pipelines. So we're gonna do slightly different from the correction, but it's gonna be same thing. So we're gonna logs receiving OTLP and file log. We go memoriator and we go to routing logs. And based on routing logs, if there is an attribute container D, container runtime, it will either go here, either go here, either go here. And last, this is going to be for the Otel logs, because there is no where it's going to use the routing logs here. And it will add the Kubernetes attributes and batch. So here you can see that I have few transform that is not existing. So let me drop those for the moment, because otherwise it will complain. And last, we will add the last piece, which is using transform. So now we have this and we are good. So let me apply this pipeline. So now no major big deal changes because we didn't transform anything. It's just now using routing. So let's just apply this one. Routing logs. There's an S in default pipelines that I forgot. So that's, again, small mistake. You see that you will have to go through that journey where you, when you apply some changes on your pipeline, you check that the collector is actually doing as expected. A small mistake again in the name of the routing. And now we should be better. All right, let's apply. What we need to do is to make the transformations. So first thing that we want to do is every single collector. So I'm going to copy, it will be faster and avoid the mistakes that I did before. I'm going to copy the transform logs. So this one. Here, we're going to name this transform. It's going to be a log statement. And this, because now we know that we have a log file path that has been added by our file log receiver. So now what we want to do is to extract the namespace, the pod, the UID, the container name, the restart count, and so on. So where the attributes exist, and if it's the case, it will store this huge map, with namespace, pod name, and so on, into cache. And then I'm going to set. So I'm going to define resource namespace, the pod name, the pod ID, and we can even create a new one. So Kubernetes container name, for example, which is because we have the value, in fact. So we could technically add this one. So let me add it and say Kubernetes container.name. And what we want is to get this piece. So now we have this one. So which means every log pipeline that we've defined will go through this one. So this is true not for OTLP, but for the file log. So file log, remember, I will clearly have the Docker. So I'm going to start with transform. And then I'm going to use cryo. And then I'm going to use containerd. And that will be the first step of the transformation. Okay, so here we have this and routing the default one with the OpenTelemetry for the one we don't touch it. So let's apply this one and see what we get in Dynatrace. Here it is, it's great. Both are running now. So which means if I go to Dynatrace, the newer log coming in, so let's run the same query that we had a few seconds ago. So now we can see from a Dynatrace perspective that the containerd is containerd, that's as expected. We have our namespace, we have our pod name, we have our container name, we have the pod ID. So all the metadata we just added. The thing that we need now is to clean up about this log here to make it readable, because the first piece is the date, then std out. So let's change this with a transform. So to save a bit of time, what I've decided to do is to copy the transform. So here transform Docker would be the one for Docker. So here Docker is going to be a JSON content. So we store all the fields into cache, and then we put log the log message into the log into body. We do the same thing with the cryo. Here we have time, we have std out, log tag, and so on. We store it into cache, and then we are extracting the log. And we do the same thing for containerd, where we have the time here. And then what we do is that based on the content, we try to get the severity number. So this is going to be the various transform. So let's add this into our pipeline now. So transform containerd would be running after, because here it's for our case, it's going to be mainly the containerd which is interested, but let's copy everything so then at least they are used somewhere. So let's apply this one. Now, so both are running. Now let's rerun our query to look at the logs coming in Dynatrace. And now what you can see here, we have obviously changed things. So here we don't have the date anymore. We still have containerd. We did set some severity in specific log format. You can see, but at the end, the actual log line, we removed the date at the beginning and the std out and stdr that were not useful for us. That's it for today's episode with our technical tutorials showing you how to collect logs from your Kubernetes cluster. As you can see, OTTL, the OpenTelemetry transformation language, is very powerful because at the end, with the combination of the file log, the routing, and the transform processor, or even filter, we can do a lot of very complicated tasks. And again, as reminded in the previous episode, if you build collector pipelines, try to do very small processing tasks. Basically just grab few information to get the right metadata back in your Observability backend. But if you start parsing your logs, the content of the logs to get more information, and this parsing is done through regex or JSON parser, then you may ask a question, do I really need to do it at the agent level, or can I do it later on the backend level? Because at the end, if you do more extract or more regex on the agent, obviously we will expect more memory consumed on the agent. The other piece, as you saw here, it's very easy to make errors when you design your collector pipelines. So that's why I also recommend to do small changes, reapply them, restart, look at the logs to see if there's an error, look at the desired results, maybe just by exporting it to std out of the collector. So then you can see if the various attributes are set. But yeah, designing at the moment, a collector pipeline, especially when you do a lot of log transformation, could be a long journey because we don't have any testing tools or any way of validating the schema. So this, I guess, will be improved by adding more features on the OpenTelemetry collector. But again, keep in mind that if you do very simple things, simple processing, you won't have that challenge because you do small tasks. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see you soon for another episode. Bye.